Okay, so again, we're making estimates via multiplication. We got one more problem to finish on 108. We did part of 108 yesterday. Read number 3 to yourself. Go ahead. Then I'll talk about it in a minute. Okay, it says, a giant anteater eats about 30,000 insects every day. An aardvark eats about 500,000 insects per day. About how many insects do one giant anteater? 50,000. I don't know what I said. That doesn't matter. About how many insects do one giant anteater and one aardvark eat in 1 year? So this time, are we subtracting?
No.
No, this time you're going to have to do some adding. And I know how much each of them would eat in a day. So what could I do for my first step? I'd probably add them first, because then I only have to multiply once. So if I was writing my number model with unknowns, I would do 30,000. Okay, you got to pay attention. You got to do what I do. You should actually be trying to think about it a step before I do. 30,000 plus 50,000, because they're pretty much already rounded. Then in an effort to make this super easy, what if we just multiplied this by 400 instead of 365 for an estimate? Okay, you should be doing the first step already. What's the first step based on how we wrote it?
50,000.
You should be adding 30,000 plus 50,000. You might have some room to work in the margins or something like that. I definitely write them down. Okay, I'm going to use this part right here on the whiteboard to do this. So we had 30,000 plus 50,000, which should be really easy to do because it's a lot of zeros. 0.
0, 0, 0, 8.
So I get 80,000. We're going to take 80,000 times 400. Now remember what I would do here is I'd count all my zeros and put them down. Then I'd do 8 times 4. Go ahead and give that a try. How many zeros should you put down?
4.
Way more than that. Well, not way more, but significantly more. 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. Now you would do the 4 times 8. Okay, when I do 4 times 8, that was a hard one for me when I was a kid. So what I did instead was I would do 2 times 8 and then I double it. What's 2 times 8? Okay, so if you can do that, and sometimes what you got to do is you got to write it down. You don't have to try and do it all in your head. That might not be on the smart board, so I'm going to turn over here. 2 times 8 is 16. I write it down because at the very least, what I know is if I need to double it, I could always do this. But some of us, we're like, oh, if I write it down, everyone's going to think I'm a dummy. Well, I can tell you what, if I saw you write that down, I wouldn't think that. I would think, hey, look at them listening to the things that I told them to do in class. And they realize that they probably can't do that step in their head. If you aren't at that point where you can do it in your head, does it do you any good to sit there and try and think, 16 times 6, 2, it's 16 times 2, 16 times 2. Does that do you any good to sit there and do that?
No.
No. If anything, that makes me go, why? That frustrates me more. This makes me happy. If this is what it takes for you to do it, again, I'm doing 8 times 2 instead of 8 times 4, and then doubling it. That makes me happy because I know then that you have a strategy to at least be able to solve it. We have to break this idea in our heads that showing our work is a bad thing. Showing your work is a good thing because then if I see you get it wrong, then I know that I can look at your work and find out where you made your mistake and I can circle that spot for you so you know where to look. When you get to the middle school and high school and you're working on harder math, it is going to be essential that you show your work. You might as well get in the habit of doing it now. When you're doing algebra and geometry and trigonometry and calculus and all other kinds, physics, chemistry has math in it. Some of you are like, oh, Mr. Ross talking again. Boo! Santa's watching you. He knows when you're not listening. He knows when you're distracted. He knows that's being naughty in school, and I hope that it doesn't affect your list of. Maybe pay attention. It's essential when you do those things that you show your work. They're going to require it. So you might as well get in the habit of doing it now. You'll be ahead of the game. Okay, for those of you that struggle with this, 6 plus 6.
12.
Figure that. When I get my 10. Okay, so, that's not good. It goes up here. 32. Count in 3 zeros, comma. Another 3 places, comma. So we got 32 million. Okay, so what you should have had here, 32 million ants, and that's just for one anteater and one aardvark. So, but now I got to ask you a question. I don't want you to blurt it. Should it be more or less aardvark, or more or less ants when we actually solve it? Don't blurt it, just think about it. More or less ants when you solve it. Brady. More or less ants. Why? What are you taking at times? So when I take 80,000 times 365, which you're all going to do with me anyway up here, you're going to participate. Everybody does everything. 365 is less than this, so it should be quite a bit less, actually. Like roughly 35 times 80,000 less. So here's what we do. Remember, we have to take the numbers that we have here in the bottom, like the 3, 6, 5. We have to take all of those times every number on the top, except when they're 0. Do we have to worry about 0? So we count, listen, because on modeling, we count the non-zero digits that are in this problem. 1. Okay, this is a 1 by, well, no, take a look. 1 times. So how many problems am I going to have? 3. 300 times this, 60 times this, 5 times this, right? So it's kind of like a small math problem. It's like a ratio, right? They're like dimensions. So we have 1 up here, 3 down here. We're going to end up with 3 problems at the end. First step, count the. So our first problem is 300. Why is it 300 and not 3? Because this 3 is in the
100th place.
So how many zeros from that? 2. I put them down in my place values so that I'm lined up. How many coming from the 80,000? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 0. Now all I have to do is 3 times 8. You do that in your head right now. 3 times 8. One thing you can do if you don't know 3 times 8, you could do 3 times 4 and double it. 3 times 4 is 12. Double that. 24. So you should end up with 24 million. Hey, I'm done with that 3 because I don't have to do 3 times 0, 3 times 0, 3 times 0, 3 times 0. Those are all going to be 0. I'm going to move on to my tens place. I'm going to do 60 times 80,000. How many zeros from the 60?
1.
How many zeros from the 60?
1.
How many from the 80,000?
4.
1, 2, 3, 4. Now I'm doing 6 times 8. So 6 times 8. I do 5 times 8 and then I add 8. That's how I do it. Here, what's 5 times 8?
40.
Then add 8.
48.
1, 2, 3 zeros. 1, 2, 3 place values. 4,800,000. I'm done with the 60. Now I just have to do 5 times 80,000. How many zeros from the 5?
0.
How many from the 80,000?
4.
If you wanted, you could put your comma in because it's there. Now I have to do 5 times 8 and write that down. Hey, we already did 5 times 8 and we did 6 times 8. This should be easy. What's 5 times 8?
40.
Wait, I have 1, 2, 3, 4, 5 zeros. I should only have 1, 2, 3, 4. How come I have 5 zeros here?
Because
Don't flirt it. I have 1, 2, 3, 4, 5 zeros. The 5 doesn't have any. 1, 2, 3, 4. I should only have 4 zeros. Why do I have 5 here? Julia. Because what? Yeah, because the extra zero came from doing 8 times 5, right? That's why we put all our zeros down there before we started, so that all we had to do was worry about putting on the number that we get when we multiply 8 times 5. Here comes the hardest part, probably.
0, 0, 0, 0, 0, 12, 9, 2.
29,200,000 is the answer. Now, Brayden already told us what we should expect for our actual answer. So does this make sense? Yes or no, and why? Okay, does it make sense and why? Chase. Okay, why? Pretty much you could just explain what Brayden explained. Yeah, exactly. It's only 3 million less, around 3 million less. Well, but when you're dealing with 32 million, I'll tell you what, if someone walked in here right now and said, there's 2 prizes up for grabs, 32 million and 29.2 million. And he drew sticks, like he came into the school and said, one of you is going to win 32 million, the other of you is going to win 29. I'd be pretty happy if I won the second prize and got 29.2. I wouldn't really complain about the 2.8 million I lost. Just being honest. I know it's a lot, but I'd be like, yep, all right. I'd be like, enjoy your 32 million. All the rest of you is I'll catch you on the flip side. And I'd be gone. I'm just saying, like, if one person won each of them, if I got the second prize and the second prize was that, and that was the first prize, it's still a lot. It's still a lot of ants. But the point is being that we multiplied the first one by 400 and we multiplied this other one by 35 less, we would expect it to be smaller. And because each time you multiply, you're taking away 80,000, right? If it was 399, you take away 80,000. You take away another one, you're timesing by 398, that's losing another 80,000. You're losing a lot every time, right? We'd expect it to be smaller and by a fair amount, 3 million. Not a whole lot, but a fair amount. So that makes sense. All right, good job. I think you guys did fine there. We're going to look at subtracting and addition because some of us still at times don't know where to regroup from, and that's okay. So we're looking at this. You're on 109. Yeah, what's up, Bradley? Oh, I skip our bathroom break. Well, it's not our time, but I'll pause the recording. Okay, so we're back from our potty break. Don't say, yeah. You guys are the ones who asked for it, so I gave you a potty break. All right, so we're taking a look at page 109, and we're practicing addition and subtraction. And all the boxes are there for is for you to write down like what would happen. So for example, do 9 plus 7. again, when I have to do something like this, what I do is in my head, I think about this as a 10, and I think about this as a 6 when I'm adding. Because it's like taking 1 away from here and putting it here. Then I can do 10 plus 6, which is 16. And what they want you to do is they want you to put the 6 here, cross out this, and then this now becomes 16. You see that? Or excuse me, no, I'm doing that wrong. I'm doing that wrong. I'm doing that wrong. I don't know why I did that. That makes no sense. You put the 1 up here because it's 110. I'm sorry. That was dumb. My fault. So then you're going to add your tens column. I was thinking subtraction. And on one like this, it's not really a great way to do it, but they've already told you that this should be a 5, so that should be a huge help to you. Figure out what should be here. Okay. What is 1 plus 6 plus 8? 15. So the 5 stays here. What goes up here?
1.
Okay, when I see something like this, and actually every time I add, I just look for a way that I can make 10. Do I have a way I can make 10 here?
Yes.
100 plus a 900 is 10 hundredths. Do you see that? 10 hundredths plus 7 hundredths would be 17 hundredths. Making sure this works and figure out what goes there. What should be up here?
1.
Because 6 plus 6 is 12, 1 more is 13, bring that here. 1 and 5?
8.
No, 1 and 5 is not 8. You guys weren't listening. And now it's recorded for all the world to see. 1 plus 5.
6.
6 plus 3.
9.
There you go. So you should have gotten 93,756. I want to work through number 2 with you because these have been in your math boxes a couple times. And you guys always come when you need to do the writing part and go, I don't get how to say what I did. So I'm going to help you with it. And these are kind of tricky as well because they don't give you this. 4 minus something is 2. So think, you can do this too. You can look and go, this plus this should equal that. What plus 2 is 4? What plus 2 is 4? 3, 2, 1, class. Okay, excellent.
We're not doing subtraction.
4 minus. Oh, it is plus. Sorry, my fault. My fault. Okay, I thought this one was subtraction. All right, here we go. So, is there anything? Then we have to think differently. Is there anything you can add to 4 to get to 2? Negative 2 is the answer. But are we going to think about this like a 2? No, we should think about it like it's 12. What plus 4 is 12? Figure that out. Thank you, Chase. It's 8. Thanks, Hadley. Sorry, Chase. Hey, thanks, Macy. All right, 4 plus 8 is 12. What goes up here? 1. How much do you have here and here combined? 3, 2, 1, class. Can you add something to 3 and get 5? Okay, good. Write in what it should be. What is it, class?
2.
2. 2 plus 2 is 4. 1 more is 5. Do this column. All right, so again, when I see a 9 and there's nothing, like there's no 1 up top here to add to it, oh, you guys aren't thinking, you guys are doing something else. And if I ask you, just go, nothing, so I'm not even going to waste my time with it. If I don't have a 1 up here, when I have a 9, I always look to see if there's a 1. So that's an easy way to make 10. But I don't have that. So instead, I think about this like a 10 and a 4. That's what I modeled over here as well. It's like taking 1 away from the 5 and putting it here, make that a 10. And then 10 plus 4 is, and I bring my 1 up here. Okay, check and make sure your thousands column makes sense. Does it make sense?
Yes.
Now, figure out your 10,000. Yes. What should it be?
1.
1. So now, where it says explain how you solved problem 2, that's for number 3, and I can't scroll it down because it'll mess this all up. This is where I would say, in the ones column, I knew I needed to add up to 12 because there was a 2. So I did 4 plus 8 is 12 and brought the 10 over to the tens place. Then I added my tens place. I didn't need to regroup. In the hundreds place, I needed to regroup again because 5 plus 9 is 14. I left the 4 because it's 14 hundreds in the hundreds place, and I brought the 10 hundreds to the thousands. Then I could just add the rest of the columns normally. That's a lot of writing, and I get they didn't give you a lot of space. But is it hard writing? It's just talking about what you did place value by place value. And I know you guys are good writers because you guys write paragraphs when we do writing class. So what I would do is I'd pretend I'm telling someone what I did, and then I just write down what I'm telling them. In the ones place, I knew that I couldn't do 4 plus something equals 2, so it has to be 12. 4 plus 8 is 12. I brought the 10 over to the tens place. Make sense? All right. Now we're on to subtraction, even though I messed that up before. All right, lots of crossing out here. So what they're showing you, you're to get confused on this, so probably a good time to pay attention, in some manner of speaking. You can't do 3 minus 8. So they crossed out this 1 and made it a 0, and then they made this 13, so you can do 13 minus 8. What I like to do when I have to subtract like that is I add up from this number to this number. So I think, how many do I need to get to 10 from 8? 2. How many more to get to 13? 2 plus 3 is? That's how I do it in my head. Now I'm a lot faster at doing that now, and sometimes I just know it because I've done it so many times. But you have, that's the method that I recommend for some of you to practice. Okay, I had a 0 minus 4. I couldn't do that, so they crossed out the 6. What's the 6 going to become?
5.
A 5. I had 0 here, but this is now going to be
10.
so 10 minus 4 is 6. Can you do 5 minus 8?
No.
So they couldn't cross out here because it's a 0, right? They eventually did, but the first cross out would have been the 7. Because it's 0 here, it would turn into a, no, it turns into just 10 because we're moving 10 10,000s is, 10,000s is 1 10,000. Did that fix our problem yet? We gotta cross out the 10, make it a, this becomes 15. Cross that out. 15 minus 8, 9 minus 5, 6 minus 4 is 2. Go ahead and finish that. Again, if I'm doing this one, I try and add up to 15. Yeah, Autumn, what's up? Not yet, because this was problem 4, and they want problem 5. I'll probably just model it for you so we can keep moving. So again, I kind of want to add up to this. I think how many 8 plus what is 10? 2. How many more to get to 15?
5,
5 plus 2 is,
7,
this one you should be able to do 9 minus 5. That's pretty self-explanatory. What's 9 minus 5?
4,
4, very good. Try number 5 on your own. You get stuck, we'll work through it in a minute, and then we'll be all caught up. Okay, in the ones column. They crossed out this 2, they made it a 1. They're going to move 10 over here, so what should we have? 11. 11 minus 4. You can't do 1 minus 5. So they, okay, this is where it gets a little tricky. If we have a 3 here, what did they cross out down here?
4,
A 4. It's going to be bigger, 1 bigger than this. So they crossed out this 4, made it a 3. We had 1 here. It's also going to turn into 11. And 11 minus 5. Eleven minus 5. Okay. Here they did this for you. 13 minus 7. That is 6. Can't do the 2 minus 3. So they crossed out the 5. It's going to become 4. This becomes
12,
a 12. But to make this into 13, they crossed it out and it becomes, so it's 11 minus 3. Lots of 11s here. And then you should be able to finish it. There's a lot of work there. 11 minus 3 is 8, and 4 minus 3 is 1. So again, if I'm doing this, and they didn't give you enough room to write, this explain how you solve problem 5. I regrouped from the 10 spot to make the 1 and 11, and did 11 minus 4. I had to regroup again from the hundreds place. I crossed out the 4, so I could make it an 11 in the tens place. 11 minus 5 is 6. I couldn't do it again, so I had to regroup from, and actually what we probably should have done here, we could have made this a 1. Either way, I think it's probably okay. No, it's too much to write. They didn't give you enough, and we need to get moving. We're never going to get done. But you guys get the process. You go place value by place value explaining it. Hopefully in a math box, it's not quite as substantial. Let's look at your math boxes. Okay, you're doing everything that you didn't do yesterday. So in this first one, Mrs. Drew ordered ribbon for her fabric store. She ordered 55 meters of red, 76 meters of white, 80 meters of blue. How many meters did Miss Drew order? Add, answer. How do you change meters to centimeters? Multiply by 10. Every meter, actually, excuse me, nope, that's wrong. It's times 100. Every meter has how many centimeters in it?
100.
100. Every meter has, right here, this is a meter stick. You look on this side, it has 100 centimeters. Now, every centimeter has 10 millimeters. That's the little lines in between. Okay? But this is a meter, so she ordered 55 meters. 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 55. 55 of these in red, 76 of these in white, 80 of these in blue. And each one is 100 centimeters. So of those 55, it's like 100, 200, 300, 400. So you take this and you have to multiply by 100. Okay, each time a baseball pitcher pitches the ball over home plate, the ball travels about 20 yards. About how far will the ball have traveled from the pitcher to home plate after 9 pitches? This times that equals that. How do you change yards to feet? Times 3, because each yard is 3 feet. So if you take this and multiply by 3, you'll get that. And if I don't know how to multiply by 3, then add it 3 times. Here's where kids mess up on 5B. They count all the jumps to solve their denominator. Some of you aren't paying attention. They count all the jumps for their denominator and go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The denominator is 10. No, because you should count all the jumps from 0 to 1. And that's your denominator. There are a couple of different answers that you could have for these ones using equivalent fractions. Questions, comments, or concerns? All right. Have at it. When you're done, you work on your snowmen.